Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. And in this December month lecture series, we are discussing about frequency response analysis. And here the topic is Nyquist Stability Criterion. What is this Nyquist Stability Criterion? Why do we need that? What is the use of Bode polar plots? We know that which is used to determine the stability of a control system. Same thing. What is this Nyquist Stability Criterion? These things are used to calculate the stability of a particular control system here. Okay, let's see what is Nyquist Stability Criterion. What is Nyquist stability? First of all, we have certain procedures to find out the Nyquist stability of a system. First thing, determine the poles and zeros. From the given transfer function, we need to determine the poles and zeros to check the valid points. Selecting a Nyquist plot, we need to select a Nyquist plot that should enclose all poles and zeros present on the right half of the S-plane except the singular points. See here, consider our S-plane. In this S-plane, we have omega starting from 0 to infinity and the in upper side at positive side. Also we have omega equal to 0 to infinity at the lower side, negative side. And we have C1, C2 and the second part. See here, same S-plane. We have marked some points. That is, we need to select a Nyquist plot that should enclose all the poles and zeros present on the right half of the S-plane except the singular points, which is represented here. See here, third one is mapping a contour. The Nyquist contour is mapped to determine the encirclement of the point -1 plus J0. What is this J? In frequency or in stability analysis or in general mathematics, R is your real part and J is your imaginary part. Here -1 plus J0, -1 is your real part and J0 is your imaginary part. In Bode plot, polar plot and magnitude and phase calculations, we use magnitude of -1 plus J0 and phase of -1 plus J0. Here normally the magnitude it is represented in real term and angle is your imaginary part, J part. -1 plus J0, which is used to calculate the magnitude and phase of a particular control system. Here the contour is drawn based on the transfer function of G of S and H of S. Here there are 4 sections, C1, C2, C3 and C4. See here, C1 it is in upper side C1 and next contour is C2 and we have in the clockwise side C3 and the inner contour is C4. See here, we have 4 sections C1, C2, C3 and C4, which is used to mapping a contour in Nyquist stability. C. A range for the first section C1. We know that the Nyquist range is from infinity, -infinity to infinity, and the value of omega in the section C1 ranges from 0 to infinity. The contour will be drawn in G of S, H of S plane with respect to the above range, and it will be the locus plot of G of J omega and H of J omega. Here G and H are your real part, J omega is your imaginary part. Range for the second section C2. Here the second section is generally of infinite radius. Here it is a semicircle of radius. The range of second section is from -90 degree to +90 degree radius. See here, the limit R tends to infinity, R e power j theta. R is your real part, j theta is your imaginary part. Here theta varies from -π/2 to +π/2, from -90 degree to +90 degree. Okay, and range for the second section C3. In the third section of C3, the value of omega ranges from minus infinity to 0. The locus of the third section is just the inverse of the polar plot of g of j omega h of j omega. Here, the resulted plot will be the mirror image of the polar with respect to the real axis. And range for the second section C4, the argument of the fourth section varies from minus 90 degrees to plus 90 degree. The Nyquist contour of this section has a semicircle of 0 radii. Here the formula is limit r tends to 0 r e power minus j theta. Theta varies from minus pi by 2 to plus pi by 2. Here we have a Nyquist stability plot. Here we have contours and transfer function g of s h of s. Here we have real part from 0 to infinity and imaginary part also we have minus 1 plus j0 for k greater than 240 and minus 1 plus j0 for k less than 240. We have 4 sections C1, C2, C3, C4 is represented here. Here the Nyquist plot of g of s h of s equal to k by s multiplied with s plus 2 multiplied with s plus 10 is represented here. In this example, we can clearly understand how Nyquist plot is plotted using C1, C2, C3 and C4 to analyze or calculate the stability of a control system. Thank you.